Hello friends, myself Niyati Chauhan, Assistant Professor at LG Institute of Engineering and Technology, Department of Instrumentation and Control. Our subject is Distributed Control System and SCADA. Chapter 3, Software Configuration. So in last lecture I have discussed about position algorithm, and in today's session I discuss about velocity algorithm. First you have to know about what is algorithm. An algorithm is description of mechanism of a particular equation by digital computer, right? Here we are using algorithm for programming, right? And also used for software, and equation used for particular function on computer. In DCS control, the digital computer computes actual movement of the valve or other final actuators. In supervisory control, required change in variable set point, right? And the final control actuation is left to an analog electronic or pneumatic controller. So we can say that for three more pneumatic or electronic controller, we are using two types of algorithm. First, position algorithm, and second, velocity algorithm. In position algorithm, we are using three more controller, right? Three more controller, that is PID controller. Okay, so in last session we know that Pn is equal to Kpe plus Kd delta E upon delta T plus Ki sigma 0 to n edt plus Pm, right? This is for proportional, this is for derivation, and this is for integral. Okay, and error is equal to set point minus variable. So this is equation number 1 and this is equation number 2. So here Pn is equal to valve position at time n. Pm is equal to a medium valve position. Kp, that is proportional mode gain. Ki, integral mode gain. Kd, that is a derivative mode gain. E is equal to error, S is equal to set point, and V is equal to variable. Okay, so we have taken Kp as a common, right? So in earlier equation, we have written Kd for derivation gain and Ki for integration gain. So we are replacing Kd is equal to Kp into Td, and Ki is equal to Kp upon Tr. So in equation 1, we are replacing this value, then we get equation number 3. So equation number 3 is Pn is equal to Kp, right? Kp taken as a common. So Kp in bracket E plus Td upon delta E, Td into delta E upon delta T plus 1 upon Tr sigma 0 to n E Td, right? Plus Pm. Okay, so we have replaced Kd and Ki. Okay, so here Kp, that is a proportional gain, right? So we can write down Kp is equal to 100 upon Pb, where Pb is proportional bend in percentage. Td is equal to rate time in minute, and Tr, that is a reset time in minute. Sometimes 1 upon R can be say reciprocal time. Okay. So for point different techniques. So for 4 point, we can write down V is equal to Vn plus Vn minus 1 plus Vn minus 2 plus Vn minus 3 upon 4, because we have discussed about 4 variables, right? So here V is variable. Now we can write delta V upon delta T. So here Vn minus V star upon 1.5 into delta t, right? Vn replaced by this term. Then Vn minus 1. So Vn minus 1 minus V star upon 0.5 delta t, because here we are subtracting by minus 1. Okay, so 1.5 minus 1, so we get 0.5. So 0.5 dt plus here we are subtracting by 2. So Vn minus 2 minus V star, right? So 1.5 minus 2. So we get minus 0.5. So minus minus here plus, right? So here we have taken minus. So this minus and minus 0.5 we have denoted by plus. So V star minus Vn minus 2 upon 0.5 into delta t. Next term for Vn minus 3. So for n minus 3, Vn minus 3 minus V star upon 1.5 minus 3. For n minus 3, we can write down here, see, for n minus 3 minus V star upon 1.5 minus 3 into delta t. Okay, so 1.5 minus 3, that is minus 1.5 delta t. Here we are taking minus common, so V star minus Vn minus 3. So this minus and this minus cancel out, then we get this term V star minus n minus 3 upon 1.5 delta t, and whole equation is divided by 4. Okay, so delta V upon delta t is equal to 1 upon delta t. We have taken delta t as a common, so 1 upon delta t, then Vn minus V star plus 3 Vn minus 1. Okay, then here we have taken LCM. So we have taken LCM 1.5. So here 1.5. So term is as it is. Then here multiply by 4. Right? So here we have a multiply by 3. Okay, so 3 Vn minus 1, right, minus 3 V star plus 3 V star, right, minus 3 Vn minus 2. Here 1.5 in denominator, so not necessary to multiply by 3. So V star minus Vn minus 3. Okay, so 1.5 into 4, because in our denominator we have divided by 4. So 1.5 into 4. So we get 6. So here delta V upon delta T is equal to 1 upon 6 delta T Vn minus 3 plus 3 Vn minus 1 minus Vn minus 2. Give equation number 4, right? We can write delta V upon delta T is equal to delta E upon delta T if the set point is constant. Okay, so we can write in place of delta V upon delta T, delta E upon delta T is equal to 1 upon 6 delta T. We are replacing V by E. Okay, so En minus 3 plus 3 En minus 1 minus En minus 2, right? Give equation number 5. Here we can say the position algorithm require that computer recalculate the full value of the val setting at each time increment. Next is velocity algorithm. If the computer output goes to a stepping motor or integrating amplifier, the computer simplify calculates the required change in val position. Stepping motor is used in turn drive, a slide wire, and the slide wire output is proportional to the correct val position. Therefore, the combination of stepping motor, digital correction and slide wire, right? So slide wire, that is analog signal to the final control element, act as digital to analog converter. Okay, so here that means stepping motor we are using in turn drive, a slide wire, and slide wire is proportional to the correct val position, right? So therefore the combination of stepping motor, right, that is a digital correction, and slide wire, that is an analog signal to the final control element, act as a digital to analog converter. Okay, in velocity algorithm, output output that is a Cheyenne is found by subtracting the outputs of two successive position algorithm calculation. Okay, so now we are doing calculation. So here psi n is equal to Pn minus Pn minus 1. Okay, we know that equation of Pn, right? Remember that. Okay, the equation of Pn, here we are using equation of Pn, right? So here we are using equation number 1, right, for Pn, and for Pn minus 1 we are putting replace n to n minus 1. Okay, so write down equation 1 here. So here n is equal to, okay, replace Pn, okay, Kp En plus Kd delta En upon delta t plus Ki sigma 0 to n En delta t plus Pn. This equation I have written from equation number 1. Okay, now we are Kp En minus 1 minus Kd delta En minus 1 upon delta t, right? Here we are doing summation for integral, right? So minus Ki sigma 0 to n En minus 1 delta t minus Pm. So plus Pm and minus Pm cancel out, right? So here psi n is equal to Kp, in first term, I am talking about first term, Kp taken as a common. So Kp in bracket En minus 1, right? Then for integral Ki sigma 0 to n En delta t, right? Next term for derivation, right? So we know that delta E upon delta t is equal to 1 upon 6 delta t En minus 3 plus 3 En minus 1 minus En minus 2. So here from equation number 5 we can write here, from equation number 5 we can write kd upon dt bracket in bracket En minus 3 plus 3 En minus 1 minus 3 En minus 2 bracket closed. And for n minus 1, right, I am discussing about here kd delta En upon delta t, right? So we have a written equation for kd delta En upon delta t here, right? And for kd delta En minus 1 upon delta t, I have a written equation for it. Okay, so here you can see for n minus 1 kd delta t En replacing by n minus 1 minus n minus 3 minus 1 minus 4 plus 3 En minus 1 minus 1 minus 2 minus 3 En minus 2 minus 2 minus 1, so that is minus 3. Okay, so psi n is equal to kp in bracket En minus 1 plus ki En delta t plus kd. Okay, so final equation is En plus 2 En minus 1, right? So here you can see plus 3 En minus 1 and we are giving minus inside, then minus En minus 1, so plus 3 minus 1, so here plus 2, right? Then minus 3 and minus 2, so minus 3 minus 3, minus side going to inside. Okay, so minus 6 En minus 2 plus 2 En minus 3, right? Here minus minus plus, so plus 3 and minus 1, so plus 2. Okay, then plus En minus 4, right? The stepping motor or its equivalent serves to sum or integrate the position y. Okay, so equation will be Pn is equal to P0 plus sigma I is equal to 0 to n psi I. So final equation will be Pn minus 1 plus psi n, right? For stepping motor, or we want to do integrate the position of value, right? The derivative mode is optional for velocity algorithm, but some small amount of integration is required for velocity algorithm. The algorithm with derivative include s. Okay, so here we are replacing, in previous equation we have a written equation of psi n, right? So now we are replacing E by V. Okay, E is error and V is variable, and we know that in earlier equation I told you delta V upon delta t is equal to delta E upon delta t if set point is constant. So we can replace V by E. Okay, and also we can replace E by V if set point is constant. So here we have a replaced in this equation, we have a replaced E by V. Okay, so final equation psi n is equal to Kp Vn minus Vn minus 1 plus Ki S minus Vn, right? Because error error is equal to set point minus variable. So error is equal to set point minus variable into delta t plus kd upon 6 delta t in bracket vn plus 2vn minus 1 minus 6 vn minus 2 plus 2vn minus 2 plus vn minus 4. Okay, so here we have included derivative. Thank you for watching video.